Okay, so let's start our lecture today. So, uh, okay, so last time we are left to show that the when we reverse the order. So when we reverse the direction. So then what happened to the So do we really like get a manual sign? So here, let's see. So uh. So this is equal to the integral from 0 to 1 of wait, was confused. Okay, so which is equal to okay, so I think this is theta at maybe I should use that. Which is the first. So theta at gamma t at no. So theta at gamma t of gamma prime t, right? Okay, dt. So yeah, let me check. Okay. So let's see. So okay, so this is the wrong form. So because it's not here. It's 13. Okay, 14 here. What happened for the line integral? Okay, so okay. Let me see. So shoot. No. Oh shoot. Okay. Define the exterior derivative locally exact. So okay, I see. Okay. Yeah, so this is true. Okay, so this is true. And then, so what happened is that okay, so what happened if we integrate over the negative one? So where the so this is equal to the integral over this gamma of this theta, right? And then let's see. So when we take the integral over this gamma tilde of theta, then what we have is so we have this one is equal to integral from 0 to 1 theta of, okay, I think this one is complete of ink, so I can throw it. Okay, so yeah, so this is equal to integral from 0 to 1 of okay. Yeah, so integral from 0 to 1 of theta of at gamma tilde t of gamma tilde prime t, right? Dt. Okay, so for line integrals, so basically I think we can do this, which is equal to the negative of integral from 1 to 0, right? Okay, so maybe let me do this. So I think instead of changing the right hand side, maybe we can change the left hand side. So so the left hand side is so the left hand side is exactly equal to okay. So the left hand side is equal to negative the integral from 1 to 0. So right. Okay. So the integral from 1 to 0 of the set yeah. So this is the wait. So this is like a differential 2 form, right? Okay. Okay, so okay, so let's assess the fact that if I turn the differential, so this is like, so basically this is like a complex, like the complex valued function, right? But on the domain 0 to 1. So basically, if you integrate from 0 to 1 of a complex value function, so what do you have? So yeah, so it's like the idea of the Riemann sum, right? Where the so but what is the sum that it okay, so yeah, so it's like the idea of Riemann sum, but if you reverse the order, then I think in general, right? So if we have, let's say, a real function, then it's equal to the limit of the partition, right? Yeah, so how am I gonna say? N goes to 0. Sorry, n goes to infinity. F of yeah, so it's like the sum of, okay, maybe sum f of xi times delta x, right? So a minus b over n. Sorry, b minus a over n. Hold on, maybe later. Okay, so okay, so here okay, I think there are two cats. One is downstairs, one is upstairs. So the one upstairs is really missing the one downstairs. Okay, but they cannot meet. Okay, so yeah, so I think yeah, I think oh, don't cry. Okay, so okay, so let's accept the fact that when you reverse order, the value get flipped. Okay, so now what we have, because because when you change the AB from here, right? So the A minus B becomes B minus A, which is becomes negative, right? So basically, and then for the same thing, right? So here, I think for a complex value function, so we just define, so we just define instead of having it as a real number. So basically we define it to be a complex number. And then we use the we use this Riemann integral. And then okay, so I think I think the question is that how we define the complex integral from 0 to 1, integral from 0 to 1 of a complex values function. Do we still define in this way when we take the does it agree with other definition, the Lebesgue? So what is the way that the Lebesgue integral of this one is being defined? So if you take okay, so maybe I'll search for these two questions. So so how does, so that f, let's say from 0 to 1 to, or like some real number to c be a and be, let's say, continuous. Okay, be continuous, then so how would the integral from 0 to 1 f of t dt being defined? And then the correspondence between the, and then so this is the first question number 1, and question number 2, the equivalence of the Riemann, right? Integration for complex value function. For complex value function and the Lebesgue. integration for complex value function. Okay. Oh, okay. All right. So maybe I think maybe I'll stop here today, and then I shall come back to next time.